This video is going to focus on the predicted probabilities that come from a naive Bayes model. So what are those probabilities and where do they come from? And then how are those used in the way naive Bayes makes a class membership prediction? And here we're going to look at a scenario with 5 outcome classes. So we're not going to be limited to just what we often see in classification examples of binary outcome situations. We're going to expand the universe of possibilities a bit. And without further ado, here are 2 package imports. So E1071 we'll use for the naive Bayes function. The tidyverse we're actually going to use for the data set. So the data set diamonds comes from ggplot. And turning off scientific notation probably won't matter here, but it doesn't hurt to run that line. That's what that line does. Diamonds is officially in the house, so welcome diamonds. And if we take a look at the structure of this data set, we can see 3 ordered factors: cut, color, and clarity. And then we have just several numeric variables here as well. And these lines, line 12 and line 13, these are going to just turn 2 of those numeric variables, caret and depth, into factors, and it's just going to be simply split right at the median. So anything at or above the median in either case is going to become large, and then everything below the median will become small. And I'm just going to, whoops, hold on a moment, just get back to where I was and run those lines. So I'll just highlight them both together and then send those through the console, and there they go. Okay, so the naive Bayes function itself is shown here on line 15, and cut is our target variable. That's going to be the variable with those 5 outcome classes. And then we see these inputs: caret, depth, color, and clarity, and that's really it. So just that little line alone, that is actually going to build the naive Bayes model. So there it goes. And then what we can do is we can take a look at the categories, and we can look at some of the numbers here that we'll come back to when we need to do the calculation. So when we look at the model object, what we get these a priori probabilities. And what these are telling us is what is the probability of any diamond falling into any one of these 5 outcome classes. So that is what the a priori is. And the a priori is important in naive Bayesian modeling. So we will definitely return to that. The conditional probabilities give us information about the membership of records in the class. What I mean by that is we can see proportional values here. Of the diamonds that are labeled fair, well, we know that 82.7% of them have a large caret value, at 17.26 have a small caret value. And I won't read all of those. I think you can see those right there, and you could also recreate the code. But what you probably notice is that these all add up to 100. So what we know is, given that a diamond was labeled a premium, we know the proportional membership among the premium diamonds as large caret or small caret, as is seen right here. And this is going to be true when we look at situations where there's many, many more classes. For instance, for color, and don't worry, it would be too painful, I won't do it to you, but I want you to know that if you added straight across, let's say we looked at the ones that have the fair outcome class, if we want to see, well, let's look at the proportions of diamonds that make up that fair outcome class as we look at them by color, all of these values across will sum exactly to 1. So we are seeing proportional values there. All right, so what I want to do is look at what if we just made up a diamond. So we're just going to make up a diamond, and I thought, well, if I'm going to make up a diamond, I might as well go large, go big. So the caret value is going to be large, the depth is going to be large, the color is going to be G, and the clarity is going to be S12. So that is, or excuse me, SI2. So I'll fix that right now. That's actually an I, not a 1. So time for a quick fix. All right, SI2. Now, that is my diamond. And what we can do with my diamond is we can make predictions with my diamond. So we can get a class membership prediction. So let's find out what that is. Well, I can run that line, and I haven't seen it yet, but I'll see it when I run line 22. And that's just going to give us a category. But what we can also get, and we're going to get this here with the prediction using type equals raw, we can get a probability of class membership in any of the 5 outcome classes. So I'm going to run that line to get that. And then let's take a look and see what each of these are. So for my diamond, the prediction of the model is that my diamond is going to belong to the premium outcome class. All right, premium sounds good. I don't really know very much at all about diamonds, but I don't know, it sounds good. Anyway, that's the predicted outcome class. And we know that because that's the result of the first thing, the pred.class. But the probabilities give us a little bit more information. This gives us a little bit of context. How confident is the model in our diamond belonging to premium? Well, it picked the highest one of those values that you see there. So premium wins, and it was not a runaway winner. Very good, and ideal came fairly close. But the whole point, as I said from the beginning, is to look at that and see where that really comes from. Why is it saying those numbers for each of those outcome classes? And to do that, what we want to do is we want to think about the scores for each of the different outcome classes. And we're going to calculate those by starting with the a priori probability of any record belonging to that outcome class. And that's important because with naive Bayes, I always want you to think of each predictor as being like a clue. And you are a detective and you're trying to solve the mystery. You're trying to determine where should this record land. And the reason I say start with the prior is because if you didn't have anything else, if you simply had nothing else to go on, no one is telling you anything, and you don't know any specific data about a diamond, and you needed to guess, or you needed to try to categorize its cut, I'd want you to say ideal, because ideal is the most common outcome class, and we know that by looking at these numbers right here. Okay, but what we're going to do, though, is we are going to figure out a score for each. So fair, what we're going to do is put right there. Okay, so that's the prior probability. Now, for each of our inputs, we have 4 inputs here in this case. We have to think about the value. We want to think about what we know about our diamond. So we know our diamond has a large caret. So what this is really telling us is that given that a diamond had a fair cut, what is the probability that it was large? That's what that number really means right there. And that value associated with large is going to be used as part of our calculation. So I am going to multiply right here, and we're going to keep going because we do have 3 other predictors to think about. And so what I'll do is I'm going to put those numbers in, and rather than explain the whole thing every time as I go, I'll just say that that number is going to be used because we know. And if you wonder, why am I choosing the large value? Why do I seem to be ignoring the small value? The only reason is because that was information we have about my diamond. So my diamond, the information's entered up here. Caret value is large, depth is large, color is G, and clarity is SI2. So on that note, let me come back here. So we have got the a priori, we've got caret, we've got depth. What we're going to need is color, and then we are going to also need, let me put color right there, and then we need one other thing, and that is SI2, and that goes right there. Okay, so I am going to pop those in, and those numbers together, so a priori times the value associated with each of the predictors, that is going to give us what we'll call the fair score. And this next step could seem a little bit tedious, so I'll just go right through it, but I'll still demonstrate it as I go. We're going to then do the same thing for the rest of the classes. So for good, we're going to go there. We start with the prior, and then what we want to do is come right down and just do the same old thing. So we are going to say, okay, what's the good score? We use the things that we know. Remember, we know the categories for my diamond for all of the areas in which for the areas that we inputted. So we knew those things about the record that we wanted to classify. We entered those into the data frame that became, quote, my diamond. So I'm going to keep just pulling through here. And what I'll do, just to even speed it up a little further, for the rest of them, I'll just enter in all of the values as I go. So when I stop, say on the prior, we have the very good score prior, we have the premium prior, and the ideal prior, and those are now in. And then for our first predictor, which is caret, we are going to start with the very good, and we're going to do it only for the category membership or the category to which my diamond belongs. And let me just make sure I'm not doing that in the wrong spot. Ideal is going to be right there, and there it goes. Okay, and then I'm going to go down to depth, and I'm going to knock those out. Oops. Control V. All right. Okay, next we'll just knock out color. So there is the color value right there for G, and we're only picking G because that is something known about our diamond. So that is one of our clues as Bayesian detectives. We know some things about my diamond. We know 4 things about it. There's also some things we don't know, but that's okay. Naive Bayes lets us use whatever we have and just sort of not know the rest. But we use what we've got. Okay, so what I'm going to do is just a couple last things. So that is going to go there. And now I've got a premium for SI2 right there. And then finally, ideal. Okay, all right, so I'm going to just run all of that. And now all of those variables are instantiated. Now what we can do, so that was probably the hardest or the most tedious or the most painful part of the exercise, because now we can actually find any of the predicted class probabilities, and the way we'll do it is I'll save a little step here. I'm going to call this sum score down here, and I'm going to say fair score plus good score plus very good score plus premium score plus ideal score. So that's going to be the sum of all of those scores that are associated with each of the outcome classes. And what we can do is we can say, okay, for this particular diamond, what is the probability that it would have that we would attach to it to have a outcome class of fair. And so what we do to answer that question, we say fair score, and then we just divide that by sum score. So we take that value, we divide it by the sum of all the values, and then we get a result, and that result, 10.1005, 10.056, 021, hey, that looks kind of like something we saw. And rather than go through all of them, I'll just show one more. I'll show the one that was predicted for our diamond, which was premium, and just to see, how did it get to that number? We're gonna just take the premium score, and we're gonna divide by the sum of all those scores. And let's see where that gets us, right there, and that looks a lot like the number that the model predicted. So that is it. I will not go into any other depth or analysis in this video about the theory of naive Bayes or conditional probability. I just really wanted to focus on the nuts and bolts of connecting the dots between what we can see in the model output and the predicted probability of class membership for any of the outcome classes, and specifically wanted to do that here in a multi-class scenario. So thank you very much for watching, and take care.